We can also perform operations on matrices, and that's what we're going to do in this video, is we're going to work with matrix operations. Now the first one that we're going to work with is addition and subtraction. And in order to add or subtract matrices, they have to have the same order. Remember that order means the same size or dimension. So those words are all synonymous. So this size of the matrix on the left, it is a 3 by 2. So remember, it's rows by columns. So this is 3 rows by 2 columns. Column 1, column 2, row 1, row 2, row 3. And this other matrix on the right that we want to add is also a 3 by 2. So because they have the same size, the same order, the same dimensions, we're able to add them. When we add them, we add the corresponding elements. So we're going to add 0 plus 1. We'll see how many colors I can get through here. 4 plus 2. 7 plus 2, so that's row 2, column 1, row 2, column 1, row 2, column 1, row 2, column 1. So 7 plus 2, and then row 2, column 2, row 2, column 2 will go into row 2, column 2. Row 2, column 2 is 0 plus 3. And then we have row 3, column 1, that's 3 plus 0. And then we've got 1 plus 4. 1 plus 4. So our answer is 1, 6, 9, 3, 3, 5. And that's our answer when we add those two matrices together. 1, 6, 9, 3, 3, 5. Okay, let's try subtraction. We have to have, again, the same order to subtract. This is a 2 by 2, and this other matrix is also a 2 by 2. So we're going to be able to subtract the corresponding elements. So 1 minus 6 is negative 5. Negative 2 minus negative 2 is 0. And scoot that back in a little bit there. Negative 3 minus 3 is negative 6. And 4 minus 7 is negative 3. So addition and subtraction is pretty good, right? It's something that is doable. I think scalar multiplication is equally doable. Order doesn't matter with scalar multiplication. It's almost like the distributive property. That 2 on the outside means 2 times the matrix. So 2 times the entire matrix. So I'm going to say matrices. Matrices, matrix. Entire, yeah, I like that. 2 times the entire matrix. So that means we're going to distribute, let's continue to show that, there we go. We're going to distribute that 2 to each element in the matrix. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and 2 times 4 is 8. And that is our resulting matrix. 2 is considered the scalar. So 2 is called the scalar. And that's scalar multiplication. Addition, subtraction, and scalar multiplication, pretty straightforward. But multiplying matrices is where it starts to get a little bit more challenging. Number 1, order matters. The size of the matrix and the order of which matrix is first, of which matrix is first, is definitely important to know. We are going to take the number of columns to determine whether or not we can do this. We're going to take the number of columns in the first matrix and see if that is equal to the number of rows in the second matrix. If they are indeed equal, then we can proceed to multiplying the two matrices. So our first matrix here that's in green, matrix A, is a 2 by 2. This is a 2 by 2. And the second one is a 2 by 3. The number of columns in the first matrix, that's going to be this number right here, rows by columns, needs to equal the number of rows in the second matrix. So the number of columns in the first matrix has to equal the number of rows in the second matrix. So in order, this is our first matrix on the left, our second matrix on the right. If these two values are equal, then we are able to multiply. And what's really super cool is that our resulting matrix will be a 2 by 3. So this on the outside is the size of the resulting matrix. Now I'm going to write this down and we're going to actually multiply these. So I've got 1, 3, negative 1, 0. And I'm going to multiply that one by 2, 1, 1, negative 1, 2, 4. And I want you to follow me here because it's going to take a little bit of patience. I'm going to highlight. And then I'm probably going to move my highlighting, okay? So I'm going to start here with the first row. So the first row of the matrix on the left and the first column of the matrix on the right. One times 2. 1 times 2. 1 times 2 plus 3 times negative 1. Okay, that's going to be our new, row 1, column 1. Row 1, column 1. That's our new entry for our row 1, column 1. Now if I want row 2, column 1, this comes down here, and there's row 2, column 1. Row 2, column 1. So we're going to have negative 1. It's not like that, so negative 1 times 2 plus 0 times negative 1. So our first element in row 2 times our first element in column 1. That's the negative 1 times 2. Our second element in row 2, that's the 0. Our second element in row 2 times the second element in our column 1. That's the negative 1. So now I'm going to start just using some gray here. I'm going to move this back up. I'm back up to row 1, but this time I want column 2. So this time I want column 2, and I might just need a little bit more room, so I'm just going to move that off to the side. So here we go. The first element in row 1 is a 1 times the first element in column 2, which is a 1, plus the second element in row 1, which is a 3, times the second element in column 2, which is a 2. Now I want to do row 2. Nope, don't want to take a screenshot. Just want to move this. There we go. So what are we going to write? Negative 1 times 1 plus 0 times 2. Now I'm going to come back up here to row 1. And I'm going to move this to column 3. Column 3. First element is 1 times the first element in column 3 is 1, plus the second element in row 1 is a 3 times the second element in column 3, which is a 4. 1 left. We have row 2, column 3. Row 2 will be negative 1 times positive 1 plus 0 times 4. And our answer is 2 plus negative 3 is negative 1. I'm going to come down to row 2. Negative 2 plus 0 is negative 2. Then I'm going to do the math for column 2. 1 plus 6 is 7. Negative 1 plus 0 is negative 1. And then I'm going to do the math for column 3. 1 plus 12 is 13. And negative 1 plus 0 is negative 1. And that is our final answer for multiplying. Fantastic. Okay, let's try another. Can we multiply these? Let's try another. We've got, first I'm going to write out the size, a 3 by 2. So this is going to be a 3 by 2. And the second one is a 2 by 3. So this tells us that we can multiply, and our result is going to be a 3 by 3. So I'm going to make this a little bit longer there. 3 by 3, and I'm not going to make the same mistake. I'll put the right hand bracket when I'm ready for that one. I am going to use my highlighter though. So I'm going to use my highlighter. I'm going to circle and circle. And now I've got 2 times 6 is 12, plus 0 times 0 is 0. Then I'm going to work down the first matrix. 1 times 6 is 6. 3 times 0 is 0. Then I'm going to multiply. I'm going to work down again. Down that first matrix, which is perfect. Negative 4 times 6 is negative 24 plus 0. Then we're going to go back to the first row, and we're going to move over to our second column. 2 times 2, 2 times 2 is 4, plus 0 times negative 2 is 0. I'm going to move this down. 1 times 2 is 2. 3 times negative 2 is negative 6. We'll go down to the third row. Negative 4 times 2 is negative 8, plus 1 times negative 2 is negative 2. We'll move over to column 3 and move back up to row 1. 2 times 3 is 6, plus 0. 1 times 3 is 3. 3 times 4 is 12, so 3 plus 12. And negative 4 times 3 is negative 12, and 1 times 4 is 4. So we've got 12, 4, 6, 6, negative 4, 15, and negative 24, negative 10, negative 8. That is our result of multiplying these two matrices together. Here's one for you to try or to think about. See what you would do first, and then come on back and join me, and we'll see how far you were able to get and how far I was able to get, and what we'll compare our answers. So I started with, welcome back, I started with the fact that this is a 2 by 4, and this second one is a 3 by 4. These values are not equal. These are not equal. Therefore, you cannot multiply. So that was actually pretty simple to multiply those two, because you can't, right? You can't. So this is what we would call undefined. So the result is undefined. So they say multiply, what is A times B? Your answer is undefined. Always make sure you check the sizes of the matrices first. Okay. I know you thought that was kind of fun. Let's see if you can really multiply. These two, you're going to be able to multiply. So let's do these two as tries. Okay. And when you're ready to check your answer, you're going to come back and we'll check our answer, and then you'll know you've got it. Okay, welcome back. We're just providing the answer here, and our answer is 9240, 18:8, and 59:26. Our answer for this second one, you better press pause if you didn't do it yet. Definitely try, make sure that you've got this. 60:45, 49:43, and 141:92. Hopefully you are feeling really good about multiplying matrices, and I think that you should be on your way. There might be one more example. Let's just say we have 3a plus or minus, let's make it a minus 2b. And let's just say A is 1, 4, 6, 2, and B is 0, 3, 4, 9. I'm not even going to do any negative numbers because it's not necessary. I'll throw a negative in there right there. I'll throw 2 negatives in there. There we go. And I'll throw 3 negatives in there. There. This way you've got some experience with the negatives. But I think you'd be okay either way. First thing I'm going to do is I'm going to say, what's 3a equal to? 3a is equal to 3, 12, negative 18, and 6. Then I'm going to say, what's negative 2b equal to? Well, negative 2b is 0, 6, 8, and negative 18. And 3a minus 2b is the same thing as 3a plus negative 2b. So since I attached that negative to the 2 when I multiplied that scalar through, I can simply add these two, and 3a minus 2b is going to equal 3, 18, negative 10, and negative 12. And that's because I did 3a plus negative 2b, which is completely allowed.